So we need to make sure we've done a couple of extra things before we get to that point. Okay, so we are looking at linear relationships, and I want you to review what we've done so far. What do we know about linear relationships so far? Jay?
That it is the relationship between 2 points. That's what a relationship is.
Just, I'd leave them on the floor, Desmond, I just want to slip it down. Sorry, the relationship just 2 points? You sure? Just 2?
Oh no, in an infinite amount.
Potentially, yeah.
And it's a constant.
Okay, so we are looking at, with a linear relationship, we have a constant change. All right? So we have a constant change in one of our variables. All right? Have we got any way of describing that constant change? Does it have a name? Does it appear any particular way? Okay, so we've got another name for it as rate of change. Could you give me, come on computer, Cameron, can you give me an example of where we have a rate of change? Yeah, so a charger could be charging at 1% per minute. All right, Liam? Okay, so we could have a constant growth or a decay in something, all right? Anything else we know about this constant change? Any way of displaying it, Liam? But what about the line?
Oh, it's the on the graph. It's like the rate. No, wait. The initial condition.
Nope. Mixing up things. We'll come back to that one. No, don't say sorry. You're right. We'll just come back to that. That's all. Steph? All right. A line is an infinite number of possible points that maintain that relationship. Cameron? Charlie, I hope you're... Well, he's paying attention, so... So a line is an infinite number of points, but is there... Sticking with this, if we have a line now, that means we've done what with the relationship? We've shown it as a... Yeah, that's what Liam was pointing out. When we have a line, what have we done? We've put lots of points, because we are... And in what way have I shown it? By graphing it. Okay. We have a graph, and we have graphed it, and when we have a linear relationship with a constant change, what shape is that line? It's a straight line. So we will have a straight line. Okay? How can I see the rate of change from the straight line? What's it called? Not yet. Gradient. The gradient of the line gives me the rate of change. All right? The gradient. What's another word for gradient? Charlie? Slope. Yeah. Do we have a way of working out what the rate of change or the gradient is? Yeah. Yeah, so we're looking at the change in the y coordinates divided by the change in the x coordinates, okay? Also written as y2 minus y1 over x2 x1, okay? Or the other way around, as long as it's, you know. So, as an example of that, we could have a rate of a change in y of 5 and a change in x of 2. What would that be if I were to put that in context? Yeah? No.
Oh wait, no, it's not a similar number.
I'm still on rate of change.
Maybe 5%.
5% every 2 minutes if we're back to our phone charger stuff, yeah? It's 5% every 2 minutes. What would it be if I had, what's the difference in the gradient or the slope if I have a growth? Yeah? Good. Yeah, so a growth model will have a positive gradient because the line goes up, whereas a decay has a negative gradient and the line goes down. Okay? We always go left to right, small to large on the x, and then we work out whether we go up or down in the y values. Jelena?
What does it say after growth and decay?
Positive, negative, shorthand. It does, plus VE, positive. Yeah. It's just, I write the VE, to be honest, the only reason I do that is because my maths teacher did when I was at your age at school. And I've just copied my maths teacher. It's just a way of differentiating between growth add gradient or growth is positive gradient. Okay? Shorthand. All right, so anyone remember another way of saying change in y, change in x? Maybe a shorthand way? It's an r over another r. It's the rise divided by the run. Okay, run being that way and rise being up or down. So a positive rise would be a positive gradient, a negative rise. So that shows you that the run is always going in that positive direction. Liam, are you focused on me or what Cameron's doing? Maybe Cameron should be sorry for distracting you. No? Okay. All right. Okie doke. So we've got all that about gradients. We've got positive gradient, we've got negative gradients. That's about how something changes. That's how it grows or it decays. Liam, what's the next thing we know about? We've got an initial condition. What do we know about an initial condition? What does it tell me, Liam?
The initial condition is the similar number between the rates.
No, not necessarily. Yeah.
The initial condition is the y-intercept.
Okay, so we've got the y-intercept. And something else we learned about the y-intercept is when... That's what we were doing last couple of lessons.
Oh, axis.
When x equals 0. There you go. Yeah. So the initial condition is the y-intercept, so we can find that, can't we? Is it in... Are you typing notes?
No.
No, you're not. Steph, are you typing notes? I just find it weird. I've not asked you to do anything on your laptop, but you're typing away. So it means you're either typing notes, which you're not, or you're doing something you shouldn't be doing. You're on Des. Right. I hope Des must help you next time. Are you just messing around with circles and graphs and things? So, our initial condition, we've got y-intercept. What about, it's not the the initial condition, it's not the intercept, but what about the x-axis intercept? What do we know about that? When y is equal to 0. How could I relate that to my real-life scenario? Not something we've talked about yet. The x-axis, or the y-axis intercept, is when x is 0. That's your initial condition. All right, but what about the x-axis intercept? How could that be related to anything? Any ideas? Think about your phone charger. What would it mean? Yeah. When the charge is zero. How long it would take for the charge to get to zero, yeah? So if we had a situation, all right, where, sorry about this, wrong line, but let's say we had a line that was our phone charger one, and it was actually a negative gradient. So what would a graph like that represent if it was a phone charging one? Starting to die, yeah? The charge is dropping. Cameron, what about you? What are you typing on? Why? It's not appropriate for now. So this could be our percentage of charge when we start measuring, and it's dropping. So our x-axis intercept is how long it takes to get to zero charge. All right, so that would be the time. So my y-axis intercept would be the initial condition. That's how much charge we start. All right. But the x-axis intercept could be how long it takes me to run out of charge. So you were looking at that last couple of lessons, how to find the intercepts, weren't you? And you just came up with the two things which we've already written down and are on the board, which is the opposite coordinate 0. Yeah, so for y-intercept, x is 0, plug it in, you find that, and vice versa. Right, the next thing we have talked about in the past, my computer's getting slow, is what equation we can match to. Okay, does anyone remember, is anyone still writing? Anyone remember the general equation of a straight line? Satya?
I don't know. Is it y equals
ax plus b, wasn't it? Or instead of a and b, it could be no mx plus c instead. We could have a y equals mx plus c. Is there any difference?
No.
No, it's just a choice of letters. What did A represent?
How much x
So tell me what it is in words we've already been using.
A is the constant, the rate
The rate of change, yeah? The rate of change, which on the graph would also be known as the gradient. And what's B? But what is it in another way?
As the original, the initial condition.
So that's our initial condition, which is also the what? The y-axis intercept. Okay? So basically now, if we know the initial starting point and we know the rate of change, we know the formula, we can work it out. And another thing you know is if you've got a graph and you can work out the initial condition from the graph and you can work out your gradient from the graph, you can work out the equation of the graph. You can do all of that now. All right? What we do want to look at today, though, is, by the way, I'm kind of pushing through a lot of this. We will spend a bit more time because it's really super important, this topic. This goes on every year. You will study something to do with this, straight lines. In fact, if you look at it, this is my M4 stuff, right? We're still doing straight lines, but with inequalities and stuff. Here's my straight line and whatever. So you will still need to do it all the time. So this is important. All right. Now, what we are going to do today, though, if you're on page 125, we need to look at some different forms of our linear equation. So we're going to look at different forms of the equation. All right. So, looking at that table, all right, on page 125, what are the different forms of the equation they're telling you about?
Slope, intercept.
Okay, so we've got, right, point and gradient is just a point and a gradient. It's not a form of the equation yet, all right? But we've got point and slope form of the equation, and that looks like y minus y1 equals mx minus x1. Okay, so we need to look at how we would get that. All right, so let's go through these one at a time so you could do the rest if possible. So I'll do the first example with you. So we have a point which is a point on the line, 1, 3, and m equals 2. What's another letter to be used for m? A. Could anyone give me a, well, if you like, your phone charger version of what this could mean? Yeah.
Every 3 minutes, well, the charge starts at 2. No, wait. The charge starts at 1, and every 3.
Nope. What does the m mean, Cameron?
The gradient, it's the rate of.
So what does that mean in terms of percentage charge? And
2% per.
which is? Just pick one. 2% a minute, right? Let's say we're going by that. 2 for 1 minute, if you like. 2 for 1 hour. 2 whatever. Okay. What does the 1, 3 represent then, Cameron?
The x1 and y1.
What does that mean in terms of?
The point that it's.
In terms of the phone?
The percentage that it starts at.
Nope, it isn't actually.
Oh.
Charlie? It's not the starting point, is it?
It means after 1 minute, there's 3%.
After 1 minute, there's 3% charge. That's what that point means. 1 minute, 3%. What would it be after 2 minutes?
5%.
5%. Every 1 minute goes up 2. So that would be another point. What's the initial condition? 0 and 1. It got down to 1%. So I can use that. Right, so I can use my gradient. Now, how do I get point slope form from this? Well, we're going to use the point they gave me. All right. So what do I know? When x is 1, y is 3. So that's these values here. So the way I put that in is I write it as y minus 3 equals 2 times x minus 1. There it is. So that's really easy then, using the point and the gradient. Okay. Now, is that all right for everyone? Can I get you then, I guess rather than me talk through all the rest, can I get you to do the other 5 quickly, just in point slope form? I'll take a breather. Okay, so let's just check then. I will do the next coordinate. It says we've got a coordinate at -4, -7, and the gradient is a half. What does that mean? Is it going up or down? Got it? Up. What's the rate of change? But what does that mean? What does that mean in terms of charge and time?
1% every 2 minutes.
1% every 2 minutes, or a 0.5% every 1 minute. So we're going to put this in, guys. We're going to put this into our formula. So remember we've got y minus y1 equals m times x minus x1. Sorry, not x2. So this x is that's the x1. And this y is that one, that's y1. So we've got y subtract negative 7 equals m times x subtract negative 4, which we will simplify, and we won't leave it by just doing that. We will actually rewrite it as y plus 7 equals 1/2 x plus 4. Okay? Right, let's move on then. We have the next method, the next form, sorry, we've already had a look at before, is gradient and intercept form. Now, gradient and intercept form is y equals mx plus c using the m and c. Let's have a look at the first one we did again. So we're back to 1 and 3 and m equals 2. So I'm back to the first one that we did. Now we've got two methods for this now. So you know that m is supposed to be 2. Yeah? So we start with y equals 2x plus c. Happy with that start? But what's c? C is the y-intercept, or our initial condition, where x is 0. Now, we don't have that. We could work it out. All right? We could work it out as, like we did already, 0 and 1. So our answer is going to be y equals 2x plus 1. However, we also have what we started with, which we had y minus 3, equals 2 times x minus 1, right? I want to show you the other way that we can get to that point, which it was. Does anyone think they know already? Cameron?
So, this equation by doing 2x minus 2.
So we'll expand the brackets, so we get y subtract 3 equals 2x minus 2.
And then you add 3 to the...
Then we're going to add 3,
And then you add 3 to the negative 2.
gets y equals
2x plus 1.
plus 1. So we end up with the same answer. All right? So, two ways to find gradient and intercept form there. Can you do that then? A couple of minutes? To work out the other ones that you did in that form, however you want to do it. Not the new one, just checking what you did. So, we have the second one, just remind you, was negative 4, negative 7, and m equals 1/2. So we could try with y equals 1/2 x plus c, and then the question is, can we do a plus c? Well, we could count up, couldn't we? But is that a nice and easy method? We'd have to go negative 4, negative 3, negative 2, negative 1, 0. We'd have a few steps. So that's a bit inefficient with our time. All right? So the plus c is a bit of an awkward one in this case. There is another way of doing it, but I'm going to stick with what's in the book. So what we have, though, already from previously is we know we've got y plus 7 equals 1/2, and it's x plus 4, right? So how can I go from this to figure out what this will be? So first step is 2. Yeah?
Is to balance the equation, so you do -7 minus. Oh no!
No,
you
not
extend
yet.
the bracket.
I expand the brackets first. Let's expand the brackets. So I've got
So
y plus 7 equals
1/2 times x
Plus-
plus 6. Y plus 6.
2. Half
Oh
of
yeah,
4,
half.
yeah?
I did that
Right, now I can start eliminating things. So I need to get rid of plus 7 by
wrong.
minusing 7. So I'm going to subtract 7 as well from over here. That gives me y equals 1 half minus 5. Good.
Wait, Mr. Potts, is this the gradient thing or the other?
So this is, what I've just ended up with, is what? This is the gradient half and intercept, which is the negative 5 form. I started it though using the point slope form. So I went from point slope to gradient intercept. Alright, question? No? Alright. Okay, so let me go on to the next form then. So I'm just going to rewrite these. So far for this one, the second one that we've been doing ourselves, we have point slope, which is y plus 7 equals 1 half of x plus 4. So that's one form of the line. We also have y equals 1 half x subtract 5, which is the what form again?
The gradient intercept.
Gradient intercept. So what we want to do now is we want the final form, which is standard form. Alright? Now the standard form of the equation looks like ax plus by equals c. Now you'll notice they've used capital letters because they don't mean the same things as before. This c is not necessarily the same thing as the other smaller c, but be careful. So, one thing to note, a, b, c must be integers. Must be integers. We're not allowed any fractions or decimals or anything. So what's the problem with this one's at the moment? Either form, we've got, what have we got in there that we need to get rid of?
The 0.5.
The 0 of the half, yeah. So what we're going to do is we're going to go from this form and we're going to end up in standard form. And what can we do then? If we've got to have integers but we've got a half in there, any ideas what we can do to get rid of it?
Times 5.5.
No, it's
By 2. If I multiply it by 2, so I'm going to have 2 lots of y, and that equals 2 lots of a half x minus 5. I've done 2 lots of both sides. So that's giving me 2y's equals x. 2 lots of a half x is x. 2 lots of minus 5 is... Okay. Alright. So we're almost there. And what's the next step then to put it in standard form? No, that doesn't do. Don't want to do that. Yep.
You put it in hours.
Nope. Don't need any powers. Steph? Well, I don't subtract it from one side and add it to the other. I subtract it from both sides. I'm going to subtract x from this side, that gets rid of it. But I must subtract x from this side too. So it becomes 2y's minus an x equals
Negative 10.
-10. Okay?
So standard form is
This is what I don't get on do. I fail every single test like this.
Right, just as a note, ladies and gents, that sometimes people write the standard form. So this is good, I'm happy with this, right? But some people will go a step further and say 2y minus x plus 10 equals 0. So there's another way of doing it, just to rearrange it so it's all on one side. Okay? Do you see what I did to get that? We add the 10. Alright, so what do I want from you? It's 2:39, that gives us 11 minutes. What I want from you to try your very best is to pick one that we haven't worked on so far, and what I want you to do is pick one that you think suits you. I want you to work out all three forms of the equation, and then I want you to satisfy yourself by going on Desmos. I want you to type in all three and see that they all come up with the same straight line. If they don't, you've done something wrong. So first step, pick one of the remaining ones that we haven't done. Pick one that you think is a nice level for you to do, because they do get more difficult. Work out all three. If you need some help, let me know. Then we'll go into Desmos, type them into Desmos, and check. You should just be able to type it into Desmos exactly the way you've written it on your page. That's the beauty of Desmos. Okay? So first step, work out the three forms of the equation, starting from a point and a gradient.
Oh wait, that was the